So hello everyone, welcome back to our channel. And guys, the first important update that I want to give you is RRB's ALP result is out. And yes, there are a lot of candidates who have selected. So I'll take some interviews with them and let you know how they prepared for the examination, what hurdles were there while preparing. So all those things will be coming in your short section also. And also I'll take the complete interview, so that will be uploaded soon. So as of now, yes, if you people have given the RRB LP examination, go and check your result and please let me know the good news fast. Okay. So today, the topic that we are going to discuss today is the force and laws of motion. So first of all, when we're talking about this topic, that is laws of motion, so there are few things that we need to understand. So if I'll go with the mechanics section, here we can say that it's divided into two sections, that is kinematics and dynamics. And dynamics. So basically in the kinematics part, we'll be discussing about the laws of motion. So here, in order to understand the laws of motion, we have to go back in some history. And what is it? So do you know, in the starting, if I link here, one of the famous persons said that all the objects have a natural place in the universe and the natural state is of the body is rest. So guys, here we are going with the Galileo Galilei's concept, where the law of inertia comes in, where according to him, if a body is in a state of rest, it wants to be in the state of rest. If a body is in a state of motion, it wants to be in a state of motion. And yes, they are not going to change their state until unless an external force is applied on it. So this concept seems like it was said by Newton also, right? But guys, Newton's first law, although it was linked with Galileo, but Galileo was the first person to tell this, and this was actually the law of inertia, which means the obstruction to change. So yes, that's the timeline. So if in the absence of the force, a moving object will continue moving, and here we can say that it was linked with the we can say that it's linked with the resistance, that is we can link it with the inertia concept. So guys, now if someone is saying, if we'll say about a natural place, if a body is kept in state of rest, it will remain in the state of rest only. But guys, just think, in this position, since slope is there, obviously it will start moving, so velocity will be there. So if I'll talk about the whole part, so Newton has concluded them with the best by giving them best statements, and there are three laws basically. So here comes the Isaac Newton, who has actually explained it in the detailed manner and the best manner. So first of all, according to the Newton, there were three laws. The first law of motion that we are going to discuss today, then the second law of motion, and finally the third law of motion. So one by one, let's understand what is it all about. So we'll start with the inertia first, because that was the root, right? And first law came after this concept of inertia. First of all, guys, what is this inertia? So inertia is actually the tendency of an body to resist the change, or we can say whatsoever the state is, whether it is the state of rest, it is the state of motion, or it is the state, it is any direction, it will obstruct the change, right? So here it's mentioned the resistance of a particle to change its state, whether it is rest or uniform motion along a straight line. So if I talk about the types of inertia, there are three types of inertias. What are they? So here we have the inertia of rest, inertia of motion, and the inertia of direction. So these are the three types of inertias. So one by one, let's take all the examples. Let's say you are sitting in a bus which is actually in the state of rest, and suddenly if that bus starts moving, you tend to fall backwards. Why? Because your body was in the state of rest, and yes, your body wanted to be in the state of rest, but because of the motion of the bus, there was an external force because of which there was a change. That is, we were talking about the resistance to change, and that's the example. So inertia of rest, it is the initial state of the body's rest, and the body is resting the motion. Similarly, if a body is in a state of motion, if bus is moving and you're sitting there reading book or whatsoever you're doing, but if suddenly brakes are applied, you will lean forward. Why? Again, now your body is actually resting that state, so it wanted to be in the state of motion. So here, inertia of motion, so the initial state of the body is in motion, so body resists coming to a stop, so it doesn't want to stop, that's why. And third one is the inertia of direction. So body resists the change in direction. The best example is whenever you will be traveling to the hilly area. So in the hill area, obviously the roads are actually curved. So once the bus turns there, so if bus is turning in the left direction, you will tend to fall in the right direction. So again, that is the inertia of direction. Yes, so these are the three types of inertias. So from this inertia only, we'll be understanding about the first law of motion. But as of now, one more thing. So inertia is actually the property of the mass of a particle. And you must remember this relation that inertia is directly proportional to the mass. And for the rotational motion, it not only depends upon the mass, but also on the distance from the axis of rotation. And this parameter is called moment of inertia. What is it? This is known as moment of inertia. Okay, fine. So guys, now let's understand the first law of motion. So again, the first law of motion is linked with the Galileo Galilei's law of inertia, that is the resistance to the change. Let's have a look what it says. So the first law of the motion that was given by Newton states that if a body is in a state of rest, it remains in a state of rest. If a body is in a state of uniform motion, it continues to be in the state of uniform motion until and unless an external force is applied on it. Seems like it is derived from Galileo Galilei's law of inertia, and that's true also. Yes, it's derived from there. Okay, so see, every object will remain at rest or uniform motion in a straight line until and unless compelled to change its state by the action of net external force. So here, a football is kicked by the footballer, and once it is kicked, so it should continue moving, right? So it will keep on moving if it is a frictionless surface. But in reality, frictionless surface is not there. So obviously there is a force that is going to oppose that, and that opposing force will stop this football after traveling some distance. Similarly, this ball was in the state of motion, and when the cricketer catched it, ball actually stopped. So that's all about the first law of inertia. Sorry, the first law of motion, right? So first law is also known as the law of inertia, and they are one and the same thing. I guess it is clear. Here, proceeding further, now is talking about the force. So what is force? So force is a push or pull that changes or tends to change the state of motion. Say, let's say either we are pushing the car, that's the first scenario that is given here, or we are pulling the car. In both the cases, we are trying to move the car. But will it be always same condition that car will always move? No. Let's say in this scenario we were discussing about car. Let's say we are pulling or pushing a train. Will it be possible? So here we will say we are trying to change the state of rest, right? But sir, it totally depends upon the mass whether it is going to move or not. We have already linked inertia was directly proportional to the mass. So here the concept is whenever there's a push or pull, there might be the change or it tends to change the state of motion. That's what force is. So force is a push or pull in which the body either changes or tends to change the state of motion. Understood? Proceeding further. So what is force? So force can change the direction of the motion. It can also change the speed and also even the shape. And that was the question that was asked in the examination. Fine. So force is what? That's a vector quantity. So which means it has both magnitude and the direction. Vector quantity. Now what is it? So guys, here you must understand two important things. One is the scalar quantity and another one is the vector quantity. So what's the difference between two? See, scalar quantities are the ones that have only magnitude. Scalar quantities only they have magnitude, they have no direction. But in the case of vector, they have both magnitude as well as direction, right? So the vector quantities have both magnitude and direction. So is there an example for the same? Yeah, there is. Let's say we have four directions here and you are standing in the mid of this road. Let's say you are standing here and you're saying, sir, I am selected in the ALP or sir, I am selected as an income tax inspector. I want to meet you. So I'll say, Acha, so that means you are in Agra. So let's say you are saying, sir, right, I'm at Bhagwan Talkies. That's the famous Choraha of Agra. Now you're asking, sir, where is your house? So I'll say it's just 5 kilometers from this location. So once you reach it, can you easily reach my home? I've told you that you have to come 5 kilometers straight. So can you easily come? No. You will say, sir, see, I am at that position, but this is the north direction, this is the south direction, this is the east direction, this is the west direction. So, sir, only magnitude won't work here. You can't just give me the answer in the magnitude, you have to give me direction as well. So, if I'll say you have to come 5 kilometers, that is not the sufficient value. So, what is required? Here, we need one more thing, sir. Please tell me direction also. So, if I'll tell you, you have to come 5 kilometers east. So, you can use this part, and yes, you can directly come 5 kilometers in the east direction. Right. So, yes, that's the perfect example of a vector quantity where we are using the magnitude along with the direction. That's it. So, like force is the vector quantity, weight is the vector quantity, right? Okay. So, here the vector sum of all the external forces acting on a system represents the net force of that system, and if the net force is 0, the object will continue to do whatever it is doing. If it is moving, it will continue to move with the uniform velocity. If it is in the state of rest, it will remain the state of rest because net force was 0, summation of all the forces was 0. So that was about force, right? So there are some numericals also, but from the coming Monday, we'll be going with a series, and that series will have the topics. And guys, in these topics, we'll do one thing that for the starting 3 days, we'll have the theoretical portion, and on the final day, I mean after the third day, that is when we'll complete 3 topics, we will have the revision of top 100 or top 200 questions, and I'll provide you free ebook every week. How's this concept? So after the class, I'll discuss about the same, but I've already discussed this with the management and just waiting for their approval. Once it is done, so every week I'll teach you in a way that obviously you will get this theoretical portion, and also you will get the free PDFs, and those will be very helpful in the examination from my past 10 years of teaching experience, by mind selection and all many candidate selection. All those experience will come in that single PDF, and you can easily revise it from here and get selected. So in the comment section, please let me know, will it be okay for you people? So that will be the regular process that we'll do. Fine. Okay, so proceeding further, now let's talk about the fundamental forces in nature. So guys, there are 4 fundamental forces in nature: gravitational force, strong nuclear force, electromagnetic force, and the weak nuclear force. So these are the 4 fundamental forces of nature. So first of all, if I'll talk about this gravitational force, so gravitational force is the one that is applicable for all the objects in the universe. It's not only for the planets or stars. No, it's for each and everything. The only thing is both the object must have their own masses, and yes, the force that is developing over them. So what is that formula for the same? That's F is equal to G m1 m2 upon r square. I'll write it for you. So that is F is equal to G m1 m2 upon r square, where G is actually the gravitational constant. Fine. And one more thing, which is the weakest force in nature. So guys, this gravitational force is the weakest force in nature. That's again the question from your previous part. And what is the strongest force? Strong nuclear force is the strongest force in nature. So that's the strongest force. All these questions are the most important ones, right? Proceeding further. Next. So forces are of 2 different types. It may be the contact forces, it may be non-contact forces. So when there is a physical contact, just see, that's the example of contact force. Let's say there's a remote on my hand, right? If I try to push it, it is going to move forward. So since it is moving forward, I'll say, sir, I physically touched this remote, only then this remote was moving. So that's the example of a contact force. What about non-contact forces? So non-contact forces are the ones in which there is no such physical contact, like that of gravitation. So if I'll talk about that gravitation example, in that, guys, there were two objects of different masses, and now let's say these both are magnets. So without even touching, they will attract each other, right? So here, without contact, that force was applicable. So that is example of non-contact force. So yeah, talking about the contact force, let's talk about tension. So here a rope is tied to this wall and we are stretching it. So here, this tension force is the example of contact force. So see, the resistance of a string or a rope against any change in its original composition is called the tensile force or the tension. So it always acts away from the tied ends. Tension is always pulling in nature. So these are the questions which are the most repetitive ones. Okay, now talking about the non-contact forces like that of magnetic force, right? So, or you can talk about the gravitational force. So the non-contact force is a force which acts on an object without coming physically in the contact with it, like gravitational force, or you can take the example of this magnetic force. Here, no need to physically touch, but still the force of attraction will be attracting it. You can talk about tides, right? So how tides are formed? So that we have discussed in the geography, but here that's linked with the physics as well. So tides are formed basically because the force of attraction that is given by the moon, because of that there are high tides and low tides, right? So yep, they all are the examples where no physical contact is required. So that's why they are non-contact forces. Proceeding further. Weight. So weight and force, that is one and the same thing. Why I'm saying so? Please remember, the unit of the weight is not kilogram. If you think the unit of the weight is kilogram, you are absolutely wrong. This is very important concept. So what is the unit of weight? So the unit of weight is Newton. This might be confusing, but that's true. So let me remove the confusion. So guys, what's the formula for the weight? Sorry, what's the formula for the force? This is m into a, which is derived from second law of motion, which we'll see in the next slide of itself. But the formula for the weight is m into g, where g is acceleration due to gravity. So they have the same formula and the same unit, where g's value is 9.8 meter per second square. Okay, so it is always directed towards the center of the earth. So here, talking about the momentum. So what is it? So momentum is the quantity possessed by an object by the virtue of its mass and motion, and that's the quantity of the motion. So it's denoted by p, and it is actually the product of mass and velocity. What is it? That's the product of mass and velocity. Okay, so here, what is the unit? See, the mass unit is kilogram and velocity obviously meter per second. So the unit of the same is kg meter per second. Sorted, right? Okay, so here we have a basic question. Let's say if you can solve it out. So the question is, two bodies having masses of 6 kg and 9 kg are said to have equal momentum while in motion. Find out the ratio of their velocities. So guys, can you find out the ratio of their velocities? So how do you find it? So just ignore the solution part. So according to the law of conservation of momentum, initial momentum and final momentum remain same, right? But as of now, they are saying they both have same momentum. So P1 will be equal to M1 V1, where M1 and V1 is 6 into V1, and momentum second is M2 V2, that is 9 into V2. And since both the momentums are same, so we can equate them. So 6 V1 is equal to 9 V2. So V1 upon V2 is equal to 9 upon 6. So that's 3 3s are 9 and 3 2s are 6. So the ratio will be 3:2. So what is the answer? The option number D, that is 3:2 is the correct option. So yes, these types of numericals are asked in the examination and you must be aware of it, right? So that's the easiest calculation, the fastest calculation that could have been done. Okay. Next, talking about the Newton's second law. So the rate of change of momentum of an object is proportional to the net external forces and this direction and in the direction of the net force applied. So the rate of change of momentum is directly proportional to the force applied. That's what Newton's second law is. And from here itself, the formula that is F is equal to m is derived. So the formula that was F is equal to m into a. This was basically derived, right? So that's the one. Next, proceeding further. So what is the unit of force? As discussed, the unit of force is Newton. And if I'll talk about even the weight part, that's also again Newton, right? So how do we calculate weight? So that's the product of mass and value of g. Okay. So talking about the Newton's third law, what is it? So for every action there is always equal and opposite reaction, right? Or every action there is always equal and contrary reaction, or we can say mutual actions of two bodies are always equally and oppositely directed. So here I'll discuss about the friction in the next class, but as of now you must remember forces always occurs in the pairs, that is action reaction pair, both at the same instant. So guys, whenever we move, as we know, so it's always a frictionless surface, but one thing, it would be easier for us if friction is more. You must remember this. So see, when you are moving, this just focus on this step. So it's like whenever we are applying force in the opposite direction, there is a friction force, and that's help us in moving also. So in the movement, friction has a very significant role. So talking about this action reaction pair, so forces always occur in the pair, so it is action reaction pair, and both act at the same instant. Let's say we are using a gun, and once I press the trigger, it will move like this, right? So bullet will move forward and recoiling will be done backwards. So it's not only about this gun, it's about the rocket launching also. The gases are there, it's moving upwards, the upthrust logic. Or you can talk about the mug which is inverted and you are pressing it in the bucket, it's trying to come upwards. That's again the buoyancy force basically. So we can link it to the third law. Yes, if we'll try to press this wall, there would be the reaction force as well. So here action reaction pairs, so they occur simultaneously, they act in the opposite directions, they act along the same line, they act on the different objects, and also they are equal in magnitude and same in nature. So these are the conditions for action reaction pair, right? So guys, today we had to discuss this part. So as discussed, from the coming week I'm planning to take the sessions in a way that in the starting 3 days we'll discuss three different topics completely, and once the topic are completed, once those topics are completed, we will directly come up with the top 100 or 200 questions, which are not only the most expected ones, but also they will include the PYQs as well. And this will make your preparation boost up. And as I told you, today the result is declared, right? It has been 1 or 2 hours only, and there are many candidates who have already shared the result. So I just want in the next result, I want your name so that I can tell in the class, see, these candidates were the ones who are preparing here, and finally they are selected. So guys, yes, just let me know in the comment section, will this concept be okay? First of all, the 3 days theory, and then complete 100 to 200 questions practice, and also the free PDFs every week. So I want this answer in the comment section. Will it be okay for you people? And one more thing, if you want to join the paid batch, what you can do? You will directly go to the Oliveboard's website. You will type the Oliveboard, and the first link that opens up, you will just click on it. Here you find the dashboard, and in the dashboard we have SSC plus Railway Super Elite batch, which includes the both English and Hindi medium courses. You have live courses. Apart from it, you will get tests. You will also get the notes. So here, once you tap it, 1200 live sessions of all the SSC exams, 600 live sessions of all the RRB exams, 300 plus concept videos, 900 mock tests, typing tests, everything is present here. So you can just click on the enroll now option, and here you can use the code select, which is going to give you 45% off along with the double validity. What is it? So the code is select. So just click here and type the code select. So by applying this coupon code, you will get the maximum discount. That's all from my end, guys. So yep, again I'll repeat, please let me know in the comment section, do you want free PDFs? So yes, if you want, I'll just discuss it with the management, and everything you will get from next week itself. So bye bye guys, take care, Jai Hind, and for the examination, all the very best. Please take care.